5th of October. We will change the feed. Okay, today is 5th of October 2020. Today our topic will be maximal flow problem or maximum flow problem. Basically both are same things. Here I have written out a problem which gives us a network. In this network, this 1 is the starting node and 7 is the final node. So we call it source and we call this end one as sink. Okay? This is source node, this is sink node. And in this type of problem, the maximal flow problem, okay, our objective is to flow the maximum number of components or maximum quantity of component or product through this network. So these digits here over the arrows, these 7 5 3 1, these digits which are beside the arrow, these actually are the capacity of that path. So for example, if you see from 2 to 5, this path, this arrow from 2 to 5 having a number 5 above the arrow. So this 5 means at a particular time in this path 2 to 5 only 5 number of products can go through. Okay, so we need to find an algorithm or a process or a system in which we can make sure that the maximum flow that can flow through the system in a certain time period. Now if you look carefully, then you see there are different number of paths. Okay, different huge number of paths are available here, like 1 2 5 7, 1 2 4 5 7, 1 2 3 4 5 7, 1 2 3 4 6 7, 1 3 6 7, 1 3 4 6 7, 1 3 4 5 6 7. Okay, so there are lots of paths and these digits are representing their capacity. Okay, now we will try to find out the maximum flow possible in this network from the source to the sink or the source to the final start to final node. Okay, that is our job in this type of problem, in this maximal flow problem. This is a very easy to solve. Okay, but little complicated. uh, Complicated means the silly mistakes plus minus mistakes might happen. Okay, or you can miss a path, so you have to be very careful whether you should not miss a path. Okay, so our target will be such that this, suppose we will take a arbitrary path. Okay, suppose we take 1 2 5 7. So if we take 1 2 5 7, this 1 2 having capacity of sending product is 7. These are might be paths, might be pipeline, might be any connecting ways. So from 2 to 5 the quantity is 5, the flow quantity is 5, and 5 to 7 is 10. Now if you choose a path which connects 1 to 5 7, you see the maximum flow that is possible is the minimum of the individual numbers. That means if you choose 1 to 5 7, the maximum flow of products is possible is 5. Because if you send 7 here, from 1 to 2 you can send 7, but these 7 number of products will not be passed through this 2 5. The path will be passed from 2 to 5 will be 5. Okay, so that's why when we choose a path, say arbitrarily taken 1 2 5 7, the minimum of it is 5. So that means through this path only 5 number of products will go through. This is the methodology. Now we have to do a tedious job depending on the network size. This is a easier one, and we will try to keep it simple. Now here we will write out all the paths possible. Okay, and when we do that, we will try to uh, update its capacity, because whenever we choose a path we will exhaust all the quantity. That means if we take 1257, the maximum flow that is possible 5, and we will exhaust the capacity 5. That means we will send the maximum number of flow possible in this path, that is 5. So we will use this path and exhaust this path. So we will send out the maximum possible through this path. As because that is 5, so we will send 5 products through this path. We could have sent 1 product or 2 product, 3 product, but we will not do that. We will send the maximum possible flow quantity. Okay, is my words clear? I hope there is no confusion. Now we will go to solving these problems. We will write out the paths and we will update our capacities beside it. So now we will write in 2 column. One is path and second one is flow. Okay, so our first path, let us take 1257. Okay, কেউ কিছু বলছো? Is anyone saying something? Okay, then no. This path we will take first is 1257. If we take 1257, as we discussed, this 1257, the flow possible is the minimum of 7, 5 and 10, which is 5. Whenever we write 5, then this 7 will be updated and there will be 2 capacity left. This 5 is fully exhausted, this 10 having 5 capacity left. Okay, so we have updated the present capacities. Okay, next path we can take 1367. 1367. Okay, 1367. If we take 1367, please reply what is the maximum capacity of this path or the
4.
maximum flow possible. 4. Very good. 4. So because in this between 10, 7 and 4, the minimum is 4, so the capacity of this path, I mean maximum capacity or the flow capacity is 4. Okay, so we will update the capacities. Here it becomes 0, here it becomes 3, here it becomes 6. Okay, now we have to look for other paths. You see, this path is already closed, so 6, 7 path is closed because the capacity of 6, 7 is 4 and that is already exhausted. So the paths which are containing 6, 7 are closed. There is no such uh, option left. So only our option left is 5, 7. Okay, now the question is, how can we use the 5, 7? The 5, 7 can be used like this. If you start 1, 2, 4, 5, 7. So if we take that 1, 2, 4, 5, 7, because we have to use 5, 7 only, 6, 7 is exhausted. That's why we will choose all the paths now connecting the 5, 7. So if 1, 2, 4, 5, 7 is selected, we take that 1 2 having capacity 2, 2 4 capacity 3, 4 5 capacity 3, and 5 7 capacity 5. So minimum of them is 2. Okay, so now we can send out only the flow 2. Now we'll update the capacities. This capacity becomes 0, this becomes 1, this becomes 1, and this becomes 3. Now this path again closed. Now we have to look for the other paths. This 1 2 is also closed, so we do not look for 1 2. Okay, so we have left only one with 1 3 and 5 7. So we have to select a path which includes 1 3 and 5 7. So if you think that way, the paths will be 1 3 4 5 7. Look, 1 3 3 4 4 5 and 5 7 having minimum capacity here is 1. So we can send only one number of products. So here capacity get updated as 5, here as 1, here as 0, here as 2. So our these two path is been exhausted, but still 5 7 has 2 capacity left, but we cannot reach on 5. We cannot reach to 5. That is a huge problem now. And 6 7 is also exhausted. Okay, so now the maximum flow that is possible through this network is the total of this, and the total is 5 plus 4 plus 2, 11 plus 1, 12. So total flow is 12 through this network. So the maximum flow that is possible, the maximum flow that is possible is 12. Okay, is the steps clear how to solve them?
Yes, sir.
Okay, okay. So this is this is how this problem to be solved. Now uh, I don't have any books with me on these problems, so that's why we cannot, I cannot give you more problems right now, but I will try to download it, or I will ask other computer science teachers so that they can send me some materials. I will try personally. Otherwise, you also try to get some solved example from YouTube or from any PDFs available. If you can get it from internet, that will be very helpful. I also try, and whenever I get it, I will of course send you to your classroom uh, accounts. I will post it there. So I hope the procedure is clear to you. Now we will advance to our next module. Our first module is done. Let me check out the syllabus. Okay, we have module 3 waiting line problems, the structure of a waiting line system, single channel waiting line, process of arrivals, distribution of service times, queue discipline, steady stage operation, single channel model with Poisson's arrival and exponential service time. Okay, so it will take little time. There are two methods to solve it. If you just can remember the 10 formulas, around 10 11 formulas, then the problem solving will be very easy. but I will suggest uh, you do it later. You, of course, you remember the formulas, but initially you need to know how do you reach to the formulas. Okay, so I will give you the basic knowledge about it. At least I will try to give you the basic knowledge, and then I will leave it to you. But if you remember the formulas, it's very easy to solve, and each problem takes only 2 3 lines to solve. Very easy one. Okay, so now the chapter is waiting line problems in your syllabus, but in books you will find is at queuing theory. Queue means line, and each and every organization which provides service or sells products faces some queue. Why the queue is formed? Because in each organization who are servicing some product, or they are selling any product, they have a counter, like ticket counter, like grocery shops counter, uh, supermarket counter. Okay, um, in garage where you repair your cars. Okay, in doctor's chamber. These are all kind of a service station where a particular type of service is being given to you, or to machineries, or to uh, any other products which needs attention. Okay, so why queue is formed, that is the problem. Now, when the number of customers which are arriving to the system is greater than the customers being served in a particular time period, so in t time period, if there is x number of person comes in and y number of person comes out in that system, if x greater than y, then there is a queue made by the customers. Now there are some terminologies you have to uh, understand. The terminologies will get there. So the arriving units which requires attention, that might be a person in doctor's chamber, that might be a car in a uh, garage, that might be railway ticket counter, again a person that are need to be serviced, need to get service. Okay, the customer might be a machine in a factory, because that need attention for maintenance. So whoever is requires the attention or get service, that is the arrival unit, and that is called customer. Now the customers, of course, in every organization or every stage, the customer does not come in a regular way. You will not find any place where the customers are coming, say, one at a time. So in every 5 minutes, one customer is coming. You will not find it in deterministic problems. You will find it in probabilistic problems. Like whenever you calculate, you will find every day and day wise might be on average there are 20 customers in a day or 25 customers in a day. In such a way the system works. We do not know exactly how much number of customer is going to come in the next few hour, in the next hour, or in next 2 hour. We do not exactly know the number. So that's why we uh, run the system for a time, we prepare some data sheet, and we check out the probabilities, and we get a probable value. And that value, as because taken according to the Poisson distribution or Poisson fashion. So the mean arrival rate in a particular time period, the average or mean arrival rate is taken as lambda. Okay, this is just a term, lambda. Lambda means in that particular queuing system, lambda number of customers are coming in at a certain hour or at a certain day, or each day or a certain minute. Okay, so this is the input or the arrival pattern. They are following Poisson distribution, and the mean arrival rate is lambda. That is the assumption of the system. Because I am saying it again, this lambda number of person or lambda number customer in the system are coming in a certain time period, that is totally probabilistic. Now, the queuing system have four parts. Number one, the input. Input means the arrival pattern, how they're arriving. This is not necessary that each and every sector the customers will come in following the Poisson distribution. This is just an assumption, because most of the cases we have seen it does not give any wrong data, does not produce much trouble. That's why this Poisson distribution is taken. Now this Poisson, what is this Poisson distribution, how it is taken, that is not required for our syllabus, for our subject. That is some statistical terms. Here we will learn only that Poisson distribution is taken and the mean arrival rate is lambda. Now, so the queuing system, in a queuing theory, the queuing system, sorry, I have made a mistake in my spelling. It's right. Queuing in theory. This is the name of the chapter. This queuing system comprises of the input, second, the service mechanism. We'll discuss everything one by one. The service mechanism. Number three, the queue discipline. Number four, the customer's behavior. The customer's behavior. Okay, these are the four important things which are consist of uh, this queuing system consists of these four things. Now we are discussing, we have already discussed the input. Now we will discuss the service mechanism. The service mechanism means in which way the products are getting serviced. Suppose there are m number of people or mu number of people. There are different uh, notations used. So suppose there is m number of people or mu number of people getting serviced in a particular time. So they follows the negative exponential distribution. So this follows the negative exponential distributions. Okay, so that means at a time m number of or mu number of people getting serviced, and they are, the service channels are servicing in a specific order, and the servicing time as a constant or random variable. So of course, if you go to barber shop or go to a doctor's chamber or go to a garage, the the serviceman, might be the mechanic, might be the barber, might be the doctor, does not take exactly equal time for each product. They take different time for different problems, because a car can take a few days while another car can take just 5 minutes. Or in case of doctor also, for a very small problem, doctor takes less time. For a larger problem, doctor might take a long time. Similarly, for repairing different machines, of course the different time period is required. So that's why there is no certain exact time period. So that's why again we have to take help of the probability analysis, and that's why we take the negative exponential distribution, and the mean service rate is denoted by m or mu. Now if there are infinite number of servers or service channels, suppose in railway counter there are 100 number of channels, then of course there will be no queue, because everybody comes in will find a counter which will be free. So there will be no queue. I am just giving 100 as an example. So that means if infinite number of service channels are provided, then the queue will not form. So when the number of service channels are limited, then queue is formed. So this in total the properties of the servicing organization. This is called the servicing mechanism or the service mechanism. Now we go for queue discipline. Queue discipline means how the queue is uh, getting handled. Like there are first come first serve basis. Okay, who comes first, he gets in the line and he will get the first service. Now there is first in first out, basically same thing. Who comes first, outs first. Now there is this first come first served is known as FCFS. Input is lambda. This is mu. This queue discipline, I'm saying the first come first served is denoted as FCFS. First in first out is FIFO. There is last in first out, which is LIFO. Last in first out. Now selection for servicing in random order. Okay, so that is SIRO, the way we take Viva in class, that is 0. Selection for service in random order. Now our last topic on this last uh, consistent of this customers behavior, that is the first one, customer behavior. The first one is bulking. What is it? The customer who leaves the queue because the queue is too long and has no time to wait or does not have sufficient waiting space, then the customer leaves. Suppose we go to library, if we find the queue is very long, then we do not join the line. भाई नेक्स्ट डे ले लेंगे बुक्स, क्या प्रॉब्लम है, ठीक है, तो लाइन में हम जमा नहीं करते हैं, चले जाते हैं. दैट इज कॉल्ड बल्किंग. नंबर 2, reneging. Renege means this occurs when a waiting customer leaves the queue due to impatience. 5 minutes he stood in the line, anybody stood in the line, and then he thought, okay, this is taking too much time, let's leave and we'll come back later. So they leave after joining the line. So that is called reneging. This is also a customer's behavior. Okay. Now there comes priorities. These people comes anytime and want their service at that instant. They do not want to join in line like our VIPs. They just get in line and they get the service and they leave. They do not wait. They just want their service at that particular time. Instant service they want. So these customers having priority over others. So these are uh, defined by the priorities. And next, the number 4 is jockeying. This is a very interesting uh, human psychology. Suppose in metro counter, you will find you are standing in a line, but the line beside you running faster. So you leave your space, you join in another line, and then you find the line beside you is running more faster. So then you again leave that line and join another line. So you are just jumping from one line to another line. That is called jockeying. This is most common in supermarket, in railway ticket counters. Okay, this happens. Jockeying happens. Okay, so these are customers' behavior. Now there is two states of a system which is called transient state, and second one is steady state. When the properties are continuously fluctuating, or the probabilities that continuously fluctuating over time, then it will a transient state. And when after a long time the line or the queuing system is steady, is not changing, its property is not changing with time, then it is a steady state. Suppose in pandals, when you go for pandal hoppings in pujas, you find whenever the the gate opens, everybody jump in to go in. So that is a transient state because the number of people coming in is random. But when a long queue is formed, and in that case, you'll find the line is going forward at a steady state and not changing with time. So then the line becomes stable. So that is called the steady state. So whenever any queuing system starts, that will be a transient state. But after some time, the properties will start to balance, will start to be steady. So in that case, the state of the queuing system will be steady state. Okay. So